Okay, page 9 of the computer programming notes, and this section is just other stuff, miscellaneous stuff that we'll use in this course. So C++ has a Boolean type. Java has a Boolean type. C did not until recently, and it's still not really built into the language. But if you include standard bool.h, then you can write code that looks like this. So bool x equals, and you can use true, false, that kind of stuff. You still have to use the regular logic operators like the double or, the double and, that kind of stuff. So true is actually a macro. So when it gets compiled, it gets turned into a 1, and false gets turned into a 0, and bool gets turned into this double or single underscore boolean, something like that. Anyway, so we'll use that a little bit. Strings in C, they're different than strings in Java or strings in C++. So a string object in those languages, it has the storage, an array that can represent your different characters, plus it'll have a variable to record the size and a bunch of operators and stuff. In C, it's a char array, and the last character has to be a null. That's how it knows you're at the end of the string. And then there are library functions that you can call on a string, like string length and string copy and stuff like that. It is a null terminated array of chars. So if you want to declare a string, you could do something like this. You could put the size in S, or size in square brackets, or if you leave it out, the compiler will automatically size it for you. So here is a string ABC. That is an example of a string literal. So constants in your programs are literals. So integers and floating point numbers are also literals in your code. So the way that gets stored is going to be like this. So here's S, and presumably if that's a local variable, it'll probably be on the stack, and we'll have the ASCII representation for A, B, C, and then the null character, you can just put the number 0, or you can do a single quote \0, and that's the null character. So let's just emphasize that. So that, whoops, that's null. Okay, so right here, this will allocate storage for S, and when you declare something and then you follow it with equals, it's an initializer. So, and initialize with the ABC string. Just as an aside, this is a question that comes up in some programming interviews. This looks similar, but it's different what's happening under the hood here. So here we have a string literal, ABC, and that is going to be stored in the text segment. So there's 4 segments when your program's loaded into memory. The text segment holds your code and some constants, and so ABC is going to be there, and so S is a pointer to that constant that's been stored in the text section. And the thing about that is that in most processors, the text segment is read-only. So if you try to use S as a pointer, dereference it, and change the first character of the string, say change A to a D, so let's just do that. So let's just say we try tried to do this. S0 equals D. So what you think you're doing is turning A to D and leaving B and C alone. But this will actually give you undefined behavior, and it will depend on the compiler and on the processor and such. But so let me just add a little note here. So this is a pointer, and it is initialized with the address of the string literal, which will be typically in the text segment, which is typically read-only, so you can have problems. So this whole thing, don't need to know. It's an aside. It comes up on programming interviews. So there you go. Lastly, C is pass by value only. So when you give a parameter to a function, you cannot pass by a reference like you can in in C++ or you do by default in Java. So there is no pass by reference. Instead, what you got to do is pass a pointer and then dereference it in your function. And that's actually what pass by reference probably does anyway. So pass by reference is really syntactic sugar. It makes your program easier to read, so you don't have to take the address of the argument you're passing and then dereference it in your function. All right.